Afternoon, everyone. I'm Praveen Maithir. So, I'm teaching assistant of this course. The course name was Symmetry, Stereochemistry and Application, and course instructor was Professor Anshuman Roy Choudhury. So, earlier classes we have studying about that structure of the molecule and how to naming that molecule and stereochemistry of this molecule like that. So now we are focusing about that how the reaction is going on in a molecule and the basic reaction of a organic chemistry was the substitution and elimination reaction. So the first problem was, so we have to arrange that following molecules in the ascending order of substitution reaction by SN1 pathway. So the SN1 pathway is like that. So where that the carbocation is more stable, so that will favor the SN1 because in SN1 reaction, so SN1 reaction, the nucleophile first liberating out from that substrate molecule and they from the carbocation, like if a example like this CH3Cl. So for the SN1 reaction, so first this Cl minus is liberated out from that molecule, so it will from CH3 plus and Cl minus coming out from that molecule. So after Cl minus is liberated out, so CH3 plus will happen. So now we have to find out that stability of this carbocation. If the stability of carbocation is more, then the SN1 pathway will be favor more. So for this methyl ion, which was reached 1 degree in carbocation, so this one will be less stable. Again, the next one is the benzylic carbocation, which one is more stable because this benzylic carbocation have. So if we draw that benzyl group, in a benzyl group, there will be pi surface into the molecule. So if there will be pi surface in that molecule, so what will happen? So this pi electron can stabilize this carbocation. So how it will stabilize this like this pi carbocation. So this electron cloud going there and this will going there. Make it plus here. So like that, this the whole pi electron cloud of this benzylic group are stabilized this carbocation. So this one is are more stable as compared to that 1 degree carbocation like methyl. So if you order the ascending order of this SN1 pathway, so that methyl one will be less favor. Will be PHCH2Cl. It's the benzylic carbocation and benzylic carbocation, the pi electron cloud will be stabilized that whole carbocation system. Now this between the PHCH2Cl and PHMeCl, if you consider this molecule, here the carbocation have both benzylic and also this one as the 2 degree carbocation. So here that the 2 degree carbocation, here only the benzylic one. So only the benzyl group, but here the 2 degree carbocation as well that benzylic carbocation, both are responsible for the stabilization of this carbocation. So for this reason, so this will be much stable than this because that 2 degree methyl, this also take place the hybridization in here. So as you know that for SN1 reaction, 1 degree is less favor between 1 degree, 2 degree and 3 degree carbocation. So 1 degree is less favor, 2 degree is more favor, and 3 degree is much more favor. The SN1 pathway. So the benzylic 2 degree is next one which is favor. SCHM. Now the next one, the stability of this carbocation, because this one the 3 degree carbocation. Also the benzyl group. This group have. So benzyl group also 3 degree carbocation. So that will be the case. The stability of carbocation for this benzyl one. B1 have the highest stability. The A1 is the next highest stability, and this C1 is the next one, and D will be the less stable. So the ascending order of the SN pathway will be like this. That methyl chloride will be least one. So the ascending order will be methyl chloride. Then this the ascending order will be D. Now the next problem. Also here we have to find out that ascending order of the substitution reaction visual follows SN1 pathway. So for the SN1 pathway, first one we have checked that stability of the carbocation. Next we have to find out that how the leaving group works. If the leaving group works after remove from that carbocation is stable, so that will favor much more SN1 reaction. So if you compare between the fluorine and chloride and bromide and iodide. So here the common was the carbocation system are same. For all of the cases, the carbocation system was Me2Cl. All are 2 degree carbocation. So both of the cases all have that Me2 methyl. So all of have this carbocation methyl. 2 degree carbocation. So all of this have that same 2 degree carbocation. So now we have to find out that stability of the leaving group. After remove that leaving group, how it's stable. So between fluoride, chloride and bromide, so iodide will be much more stable because iodide the size, the ionization potential of iodide is very much because iodide size of the iodide is very large, so it will be much more stable. Also IP ionization potential is less. Because ionization potential is charged by radius, so for all of the cases the charge is same, but the radius for iodide is less, so it will be less reactive for any substances. So iodide will be fastly leaving from that system, but chloride will be much more negative one, and it will be not to not to readily go from that compound. So for that cases, the in that compound where the iodide will be there, so that will be favor SN1 better than as compared to that where the fluoride, bromide, and chloride. So that's that a ascending order of SN1 pathway will be like this. So that fluoride will be less one. So A, then fluoride one, C, then the bromide one, B, and then the iodide. So for that SN1, what we have to find out? So for SN1, we have to remember two things. One is the for SN1, what we have to remember. So first we have to remember. First point was the stability of carbocation. So for SN1 reaction, mm, what we have to remember that first one is the stability of carbocation, and second one is the stability of the leaving group. So after removal of leaving group, how that leaving group are stable or not. So two things we have to remember for SN1. So stability of leaving group. So for also that in SN1, because that the for SN1 the carbocation is from, so we have to remember that the SN1 will favor when the polar protic solvent is present. Polar protic solvent means when that some water. Protic solvent means when that some hydrogen are present in that solvent like water, methanol, like that. Stability of leaving group. Third one, the polar protic solvent like water, methanol. This will favor for the SN1 reaction. Water, methanol, like that. The SN1 reaction, what we have to remember? So we have to first uh, tell about the stability of carbocation. If the stability of carbocation is much more, so then that will be favor SN1. And second, we have to know if the stability of carbocation for all of the cases like this. So then we have to find out the stability of this that living group. That after removal of living group, how the living group is behaved. If the leaving group is like iodide, bromide, which are much more stable in that solvent, so that will be favor SN1. And we have to remember, because the SN1 reaction is in that carbocation is from, and the carbocation is much more solubilized in the polar protic solvent. So SN1 will be favor when the polar protic solvent are present. So now the next problem one. So predict the products of the following reaction. So here the compound is like this: pH, CH, CH3, CH2I, and the reactant will be OH minus and water. So if there will be some strong nucleophile group is present, and there will be some, this one is 1 degree or 2 degree carbocation. So after removal of iodide from here, so there will be CH2 plus. So this one is a 1 degree carbocation. So if we like 1 degree carbocation and there will be some strong nucleophile like OH minus are present, so that will favor SN2 pathway. So if this will be SN2 pathway, so what will be our product? So this OH minus will be attack here and iodide will be leaving and SN. So the product of this reaction will be pH is CH3 CH2OH. Now the next problem one. So where that are when the water has a nucleophile, so as compared to OH minus, the nucleophilicity order of OH minus and water is a very weak nucleophile and OH minus is a very strong nucleophile. So this one is strong nucleophile and water is a weak nucleophile. So when there will be weak nucleophile, so then there will be chance of that our reactant this. So this have chance to make as arrange like favor that SN1 pathway. So when there will be strong nucleophile, so that will be favor weak nucleophile. So when there will be strong nucleophile, that will favor SN2 pathway, but when there will be weak nucleophile, so that will be favor the SN1 pathway. So strong nucleophile favor the SN2 pathway, nucleophile favor the SN1 pathway. Then what will be the product? So first for SN1 pathway, so first that iodide will be leaving out from that system. So what will happen? So if the iodide will be leave from that system, so this molecule will be like this. There will be some positive charge will be generated here, and here the above is methyl group. So now that water, so water as a nucleophile, So water can attack from above and below the plane like this and like that. So for SN1 pathway, so there will be two product can be possible. So the what will be the product? This one is methyl. So one cases, so this will consider as a dotted line. One cases which is below the plane. Another case will be which is above the plane. So what we have to remember? So if any reaction where the strong nucleophile are present, so that will favor SN2 pathway. So SN2 pathway and SN2 pathway always favor the reaction in anti-periplanar. So always that attack of the leaving group that below the plane. And for SN1 pathway, so when there will be carbocation form, so there will be two chance of attack the leaving group, some the above the plane and below the plane. So that time the two product can be possible. But in SN1 pathway, there will SN1 pathway there will be possible of two product, and if it will favor the SN1 pathway, so that will giving the one product, and SN2 they will be giving one product. Now the next one. So predict the following reaction. So here we have to find out that the strong nucleophile will attack here. So what will be the reaction? So that strong nucleophile. So this will be some nucleophilic region like chloride or bromide. By mistake, maybe here given the hydrogen. So that will not consider. So any nucleophile like chloride, bromide, or iodide. So here the case is that strong nucleophile. So I'll tell that when the strong nucleophile. So then that SN1 pathway, SN2 pathway will be favored. So the reaction will be follow the SN2 pathway. So if the SN2 pathway will favor, so now the product will be working. So our nucleophile is the below the plane. So the attack of the our nucleophile will from the above the plane. So what will be our product then? Then our product will be like this. So which will be attacked from the above the plane. So the above. So what we remember for SN1. So SN1 there will be some weak nucleophile. So that have chance that our substituent can produce first the carbocation, then the nucleophile will be attacked for that weak nucleophile, but not strong nucleophile. Not that have much time is there, so that strong nucleophile can readily attack into our system, and the living group will be liberating out. And also that attack of the nucleophile will be if the nucleo if the living group is the below the plane, and the nucleophile will be attacked from the above the plane, and if the nucleophile is the above the plane, nucleophile will be attacked from the below the plane. So here the nucleophile is the below the plane, so the living group is the below the plane and nucleophile will attack from the above the plane. So the product of this reaction will be like this. Now the next example, one that Br and Me and some we have given some heat. So for this reaction, this one may favor E2 and SN2 reaction. So if you favor this reaction E2 that is the elimination reaction. E2 means the elimination reaction and some unsaturated, that is the double bond will be coming. So for the strong nucleophile I have tell that there will be favoring of SN2 reaction. So if we do like this, one is SN2, so then what will be product? So the SN2 product will be like this. So this is the below the plane OH. This one is methyl. This one will be our SN2 product. Now the elimination product. Now the elimination product, E2 product will be like this, where that E2 product was the anti-periplanar friend. So our hydrogen will be anti-periplanar than the bromide. So this one is our leaving group. Bromide is our leaving group. So our hydrogen will be some below the plane, anti-periplanar. So E2 product will be like this. So now this OH minus will abstract this hydrogen, and that's become water, and this will become here, and that bromide will be liberating out. So what will be the E2 product? So E2 product will be like this. So first the cases. There will be double bond. Another E2 product from this, because this methyl is above the plane, so there will be one hydrogen which is the below the plane. So that will also consider. So that the cases. So OH minus will abstract this proton. So what will happen? So there will be double bond and Br is liberating out. So for these cases, the E2 product will be plus. There will be two E2 product. So now the double bond will be here. This will be our methyl. So in this problem, that both SM2 and E2, so these two are E2 product. SM2 and E2 will be favor, and for SM2 reaction, so the nucleophile will be attacked from the below the plane. So this OH minus will be attacked below the plane. So leaving group is out. So the product will be like this OH Me, And for elimination reaction, so elimination reaction for E2 always favor in anti-periplanar plane. So that bromide a living group and that hydrogen will be anti-periplanar. So bromide will be above, so the hydrogen will be below the plane, and if the bromide is below and hydrogen should be above the plane, so that hydrogen abstraction will be favor. So these two are E2 product. Now the next problem one. So similar the cases there were that like earlier, but here that one hydrogen is the above the plane. So this from this side, so this side that E2 reaction not favor, and here the two hydrogen, one is above the plane, one is below the plane. From this side that reaction will favor. So now this OH minus will be at abstract from this hydrogen. So now the E2 product, only one E2 product will be favor. So now the E2 product will be like this. And our below the plane is methyl. But from this side this will be not favor because for the E2 reaction, so the R, so E2, the anti-periplanar position of the leaving group and abstract from hydrogen is must there. So there will be a single E2 product. And what will be the SN2 product? The SN2 product will be this. So our leaving group is above the plane. So our nucleophile should be this one is Ame. Nucleophile also below the plane, which so the SN2 product is like this, and E2 product will be like that. Now, now this the cases where the leaving group is bromide. So for these cases, here also SN2 and E2 reaction is favor. So for these cases, so our the plane is bromide. Our nucleophile is OMe minus. If the bromide is liberated, so there will be plus here. If bromide is liberated, so what will be the cases? It will favor SN1 or not. So I will find out if bromide is liberated from here. So positive will be here. So this one is a 1 degree carbocation. really curve pattern. So that will be not much favor. Also our solvent Wooded carbon that will be not favor that SN1 or SN2. So here the SN2 will be much more favor. So due to our nucleophile, so that nucleophile will be attack here from the below the plane and the Br will be leaving out from the system. So the SN2 product will be, so it will favor the SN2. So the SN2 product will be, this will be the one product. Now the next one, what will be the other E2 product? So for the E2 product, so the liberation of hydrogen will be like this. So Br. So for the our hydrogen should be anti-peripheral. So this one is CH2. So there will be two hydrogen. So two hydrogen. So one hydrogen above the plane and one hydrogen below the plane. So that below the plane hydrogen will be abstract by OMe minus. So OMe minus is our leaving group. So this will be abstract to this hydrogen. So that bond will come in here and the Br is leaving out. So if this is the cases, so now the double bond will be like this. If the next the cases in that, so this OMe abstract this hydrogen because this hydrogen and bromide should be antiparallel. One is the above the plane, so that should be below the plane. That will come here and Br is liberating out. Now the product will be like that. So the product. So the double bond will be here. So the product will be like this. So this one will be our E2 product. And this one is the SN2 product. And if they give the SN1 product, so then what will be the products? And then will be two product will be favor. One OMe is above. So if I summarize all of these things, So first we have to that ascending order of the SN1 pathway. So for the SN1 pathway, we have to find out two things. One is the stability of the carbocation. So if the stability of carbocation is much, so then that would that will be favor the SN1 pathway. So for this the cases this one that high stability one that B, because here that both the 3-degree carbocation also the benzylic carbocation will favor. So for that cases, so the B1 will be more stable. Then the next one that 2-degree carbocation and benzylic one. Then next one is the A will be next stable. And now that between the methyl chloride, which is the 1-degree carbocation, which is less stable one, and that benzylic carbocation PHCH2 plus is much more stable as compared to 1-degree carbocation. So that will be much more stable carbocation as compared to the methyl carbocation, so that SN1 pathway will favor that benzylic one. So now the next problem one. So for the SN1 pathway, you have to remember that stability of carbocation, and after the leaving group, what are the possibility of leaving group stability. If the leaving group is much more stable, so then that will favor much more SN1 pathway. So both of the cases that carbocation are 2-degree carbocation. So for that, so that as compared to carbocation all are same, but that if we show that leaving group, one cases is fluoride, another is bromide, chloride, and iodide, and so on. So that so for that cases the iodide will be much more better leaving group as compared to fluoride, chloride, and bromide. So for that iodide will be favor that more SN1 pathway. So the D will be highest one, then the B and C, and then the F. And also we have to remember that the SN1 pathway will favor when the polar protic solvent are present, and SN2 pathway will be favor when that some polar aprotic solvent like DMSO and acetone solvent is there. So from these cases, this one that CH2 plus like a 1-degree carbocation, and if this is a 1-degree carbocation, so that will favor the SN2 pathway. And also you have to remember that there will be some strong nucleophile like OH minus is present, so that will favor the SN2 pathway, and weak nucleophile generally favor the SN1 pathway. So strong nucleophile can readily attack here, and that leaving group will be liberated out. So our product will be like this. Now the next example, if we give the some weak nucleophile like water, then what will be the cases? So weak nucleophile that will favor that SN1 pathway, and if the SN1 pathway, so first the carbocation will form, and if a carbocation is formed, then there will be two possibility. So then a nucleophile can be attacked from above the plane and below the plane, so that SN1 product is always from the two product will is there for SN1 pathway, and for SN2 pathway single product will be from. So now the next example, if we give that strong nucleophile like this, so OH minus readily attack here, so there will be no possibility to form carbocation first, and then it will follow the reaction. So here the directly the nucleophile will attack here, and leaving group will liberate it, so that will be for SN2 pathway, so that product will be like this. So and that for SN2, if the our leaving group will be below the plane, so the product that attaching of our nucleophile from the above the plane, and if the nucleophile is the above the plane, attaching of our nucleophile should be below the plane like this. So now the next example, we have to find out the following reaction pathway. So here the our nucleophile will be strong nucleophile, so that will favor the SN2 pathway. So if the favorite SN2 pathway, so that OH minus attack from the behind the Br, so Br is liberating out, so the product will be from the below the plane OH, and the methyl is already above the plane, so this will be our SN2 product. Now that will be also favor that at heating condition, that will be favor the E2 elimination reaction. So if that will be elimination reaction, then the elimination reaction for E2, so that will happen the anti-periplanar. So if the bromide is here, so H should be anti-periplanar as compared to the leaving group. So here the H is the anti-periplanar. So there will be two hydrogen, one is above the plane, one is the below the plane. So the below the plane hydrogen will be abstract by that nucleophile OH minus can abstract this hydrogen, so that bonding electrons comes here, so make it double bond and bromide is liberating out, so we give this product. Now the next from the this side also, so here the methyl is above the plane, so there will be some hydrogen that will be below the plane. So if there will be no hydrogen, if the methyl will be above the plane and H will be below the plane, then there will be no. Sorry for network problem. So if the cases, so the E2 product will be always in the anti-periplanar plane. So the as compared to leaving group, so our hydrogen should be anti-periplanar of this. So if any site have the no option of anti-periplanar hydrogen, so from this side that reaction will be not favor. But here there are two hydrogen is possible anti-periplanar, so the two product will be from here. So the for the first case the double bond will be here, so these the cases, and then next one, so there will be double bond and Br is leaving out, so the product will be like this. On the next example one, so here from methyl it's below the plane, so the hydrogen will be above the plane, so from this side the reaction will be not take place because this hydrogen and bromide are not anti-periplanar. So this side reaction will be not taken place, but from this side the reaction will be take place, so that OH minus takes this hydrogen, so this hydrogen that electron is come here, then bromide is leaving out, so the ET product will be like this, and the SN2 product, so that OH will be below the plane and AB will be also the below the plane. Now the next example, So if the bromide is leaving out from that system, so this will be the carbocation. So this will be 2-degree carbocation, and for the 2-degree carbocation we know both SN1 and SN2 will favor. So if that SN1 will be favor, so then the two product will be from this reaction, because this OMe, that leaving group is our leaving group OMe minus. So OMe minus can attack from that above the plane and below the plane. So then the two product will be from the SN1, and it will favor the SN2 pathway. So then OMe will be attacked from the below the plane. Br is leaving out. So then the product will be like this SN2 product. Now the E2 product will be like that. So for the E2 product, our hydrogen should be anti-periplanar to that leaving group. So this hydrogen is anti-periplanar. The OMe minus abstract this hydrogen. So there are some. So this will be double bond. Br is leaving out. So one product will be like this, and the next product. So OMe minus is abstract this hydrogen, and this bonding electrons comes here. So this become double bond, and Br is leaving out. So the product will be like this. So today's classes we have understood that SN1, SN2, E1 and E2 reaction, and what are the that reaction condition where the SN1 is favor and where the SN2 is favor and where the E1 is favor and E2 is favor. And after SN1, SN2, what are the product will be from? For generally SN1 we have from two product because the carbocation is from, and that nucleophile can attack from two side. For SN2 that will be single product will form. For E1, E2 there will be possibility of single product and two product is formed. Generally the E2 are favor when the strong base and poor nucleophile is there, and that SN2 will be favor when the strong base and good nucleophile. So E2 will favor when the poor nucleophile, and SN2 will favor some strong nucleophile is there. And SN1 will be favor when there will be some polar protic solvent, and SN2 is favor when there will be some polar aprotic solvent. So like this condition will favor the SN1, SN2 pathway. So that's all for this today's problem session. So we meet next week. So if you have any doubt, we can contact here. Thank you.